So I had an issue with my recording. So I had to. There you'll see a couple of things that didn't exist a few minutes ago if you just transferred over from the last video. I apologize in advance for the fan. It was getting very warm in here, and I am very toasty. I'm getting a little on the toasty side, so I just had to do that. So anyway, we're going to create an enemy generator, just like we did with the building generator. So this one's going to be called. We're going to create a game object called enemy generator. And then we are going to create a script in the enemy that I've already created because I screwed up the video. Is the enemy generator class. There's still nothing in it. We haven't touched it yet. But there is I did create it. So I just created a new C# script called enemy generator. So in this case, enemy generator will attach to the enemy generator object right up here. And then we're also going to create a prefab for our enemy. So let's create a 3D object. Oops. Not an empty object, a 3D object capsule, just like we did before. And then I'm going to call this capsule enemy, right? So then enemy, we're going to create a material. I already created the material, just like we did before. Create material, and then just change the color. In this case, we changed the color to red. And then we're going to apply the enemy mat to the enemy. So the enemies stand out as these bright red things. So this is our enemy, and we have our enemy generator. So in our enemy generator, we're going to open up the enemy generator script, and then we're going to create two public values, or three public values. First one's going to be game object enemy prefab, just like we did with a lot of the other prefabs that we've seen, especially in the city generator, which is the building prefab. So now we have our enemy prefab, and then we're going to do a public float arena size, or arena size X equals, we'll do 50 for now. That'll be our default size, and then we'll change it later in the editor. So arena size Y is also 50. So these values are, these arena sizes are going to be how much space that we have to put these objects in. In this case, just like we did on start, we're going to have a for loop, but this time we don't need a nested for loop. We just need a single for loop. So for int I equals 0. I is less than or equal to. Now what are we going to do? There's going to be a public int, because we can't have half of an enemy. Enemy count equals 100. So we're going to spawn 100 enemies. So is less than or equal to enemy count. In this case, actually, we're going to spawn 101. So let's spawn only 100. So just don't put the equal sign so that we only do 0 to 99. And then last but not least, I plus, so that we increase I every iteration. So in this case, now we can just instantiate a enemy prefab at new vector3 so in this case, we're going to do the x and z coordinates, just like we did with the building scale. We're going to do random.range arena size, or sorry, 0 to arena size x. And then 0, we're going to make it 1 because I know the height is 1, and then we need it to be 1 so that they don't end up buried in the ground. And then finally random range 0 to arena size y for the vector size. And then finally we need the quaternion identity. So now it'll instantiate an enemy prefab at a random amount between 0 and 50 in the enemy prefab type. So let's go to our enemy generator here. And now it needs a prefab, so let's go back over here to our prefab list here. And then let's drag our enemy into the prefab list, and we can delete the enemy from the scene. And then go to enemy generator, and then attach this prefab to our enemy prefab. Again, we could also click the button, look at all of our assets, and click the enemy object. So now that we've added the enemy to our enemy generator, let's see what happens. So we run the game, and it creates, bam, exactly what I expected. From 0, 0 to 50, 50, it creates a bunch of objects. A bunch of enemy objects. So it just creates a bunch of them. Now the thing with these is that if we were to go into our game here, we can walk up to them and bump into them like buildings. They don't move. So what's wrong with them? Well, in this case, they don't have rigid bodies like we expect them to. So let's go back to our enemy prefab here and add a component physics rigid body. And just like the players, because we want them to stay standing up, we're going to freeze the rotation on our X and Z coordinates, but not on our Y because they can rotate. So now, when I go back into the game here, we will see a green wall. So now we can walk up to the objects and kind of bump into them and push them around because they actually exist in physical space. And so that's cool. That's a really cool spiel here. That's something that they managed to do. So now they kind of just hang out, right? So now the next thing we want to do is we want to be able to shoot them. So what we're going to do is add a new script to them. So let's go back to our enemy folder and create a C# script called enemy health. And so this enemy health class is going to contain everything you need to know about enemy health. So reload. So enemy health. So we're going to do public. We'll do a public float. ENEMY. No. Enemy max health. And then we'll do a float current health. And then on start, we'll set the enemy current health to enemy max health. And then comes some very interesting things. So now we want to create a new method called public void. We'll call it apply damage. Okay? So now we have, and we want this apply damage method to take a float damage amount. Right? And so on apply damage, enemy current health minus equals damage amount. Right? So we want to know on apply damage, why am I using this? We apply the damage amount, so we subtract the damage amount from the current health. And we want to kill the enemies, so if enemy current health is less than or equal to 0, so it has no health left, then we want to destroy this .gameObject. So in this case, what this tells you is that it destroys this game object. It'll destroy itself. That way it deletes itself from the game. It looks like it disappears. So that's cool. And so now we have this public void apply damage. Now, how do we apply damage? In that case, now we're going to want to go to our object folder. And this is the reason I created this separately from player or anything like that, because this is where other objects that aren't enemies or players. In this case, we're going to create a C# script called arrow damage. So this is for our projectile that we haven't created in the Unity yet, but this is going to be the script that that manages dealing damage to that. So in this case, we're dealing with collisions. So we're going to create a void on collision enter. So meaning when the collision, so when two objects collide, they call this on collision enter method. So collision, we'll call it collision call, COL for collision, or COLL, right? And so now this collision object, right, returns us actually the call.gameObject. This game object that it has inside call is whatever it collides with, every single object it collides with. So what I can do is I can do gameObject.sendMessage apply damage, and then I can tell it. We can create a, for example, we can create a public float arrow damage equals 1F. And so we can send arrow damage. But this time, so similar to what we did before with the send message for the player, we can send message options. In this case, we want to send a don't require receiver because this arrow could hit a wall that doesn't have this apply damage method. And if it has a receiver, if I require a receiver, it'll throw an error. So in this case, I just want to send apply damage to every single collision object that this arrow collides with and apply the arrow damage to it. Let us create our arrow. So in this case, I'm going to want to create a 3D object cylinder. First I'm going to create a empty object, and I'm going to call it arrow. Nah, please. And then, so inside that object, I'm going to put the cylinder, which is going to be rotated at 90 degrees, and then be a 0.01, 0.01, so it's going to be very, very thin. Actually, you know what I might do, like 0.05, because I'm saucy. I might make a nice thick arrowhead. And then, because we're just using some basic objects, I'm going to add a cube. This cube is going to have a width of 0.1, so that's our arrowhead width. Actually, you know what? I have to go down because back down to 0.01, because I'm going to use 0.05 for the arrowhead. So there's that, and then the cube is going to be a 0.05 by 0.05 by 0.05. So now we have this little cube here, right? Fancy little cube. And this cube will go, well, first let's lower our cylinder down to like 0.5. And then our cube will go at the end of this. I can actually make the width 0.1, and then we're going to actually rotate it on the X value by 45 degrees. A little saucy here. 5. So now it looks like a little, a tiny little arrow tip. So actually we're going to increase these to 0.1 and 0.1 to make the arrow tip look a little bit bigger. And then we're going to clone that arrow tip 2 times, and we're going to say z is -1, or -0.5, and -0.5. And then the y value is going to be 0.1, or actually 0.05, and then the other one is going to be -0.05. So this creates our little arrow here. So let's go to materials and then create a folder for arrow meth. We'll call this arrow mets, and then create material arrow head. Create. Oops, I don't want to see sharp script. I want a material, and I'm going to call this one arrow shaft. And then create a material arrow tail. So this one is going to be, we're going to make it like a blue color for the tail feather things here. So we can just throw that on there. And then the arrow shaft is going to be a brown color. And then the arrow head is going to be a light gray color. Not to be confused with the building color. So there's our little makeshift arrow thing here. Right? So, now that we've got that, we're going to strip these of all of their colliders, because we don't actually want any of them to have colliders. So right now they have no collider. They're colliderless. And the reason we don't want colliders on these objects is because we're going to put a collider on the entirety of the object, a box collider, attached to this. So now we can make the box collider 0.1 width, so that we can, or actually 0.05 width. We make it 0.05 width, and then our Y is going to be 0.1 height. So it doesn't have to, and I mean in this case it doesn't have to be perfect. In this case, what I can do is I can start setting some things. So like I can do like pull this back to like 0.4, and then I can make the cylinder like a 0.4, and then I can pull these in to a point. Actually, we don't want it, but I want these negative 0.4, and this one as negative 0.4 as well. And so that way it fits in the box a little bit better. And then I can adjust this to 0.98 or 95, 4. Yeah. So there we go. So that fits. The tail feathers don't really matter. They can clip through things. But for the most part, the arrow is a box that is about that big. So now we know how big the box is and how it works. So now we can create a prefab of that. So now we know what the arrow looks like. So let's go back to our prefabs folder and create a prefab for our arrow. So now we have our arrow object. And then we're going to actually make sure that the arrow object adds a component script. This is another way to add scripts so you don't just drag them. In this case, I'm adding to the prefab of the arrow damage script. So arrow damage is going to be 1. The enemy is going to have a script, so let's add the enemy health script. So the max enemy health is going to be 1. So in this case, 1 arrow kills the enemy. So I should apply 1 damage to the enemy, and the enemy should die with 1 damage. So in this case, we could always test it, but by dragging an enemy and then dragging an arrow directly on top of the enemy, and if I run it, yep. Where's the other enemy? Let me close city generator. Arrow 1. I need to drop it. Oh, you know what this doesn't have? Physics rigid body. Boom. Now it has a rigid body. So I forgot to add the rigid bodies to the arrow objects. So let's add the rigid body component to the arrow object. So now the rigid body has an arrow. Now all of the arrows have a rigid body component. So now when the arrow falls on it, it kills the enemy. So that's perfectly fine. So now we know that the arrows work properly on enemies. So now we have to launch them. So let us go back to our player, and instead of player movement, because we don't want to do player movement, we're going to add a C# script called player shoot. So in this case, the player shoot object. Let's open up our player shoot script, and this one's going to have a public void method called fire arrow. But it's also going to have, because we're talking about arrows here, obviously we have to be able to charge the arrows. So we're going to have the charge. Why am I having a hard time figuring out how to spell charge? Charge arrow on this object here. Now the reason we're having two separate values is on click down we begin charging, and then on release we fire arrow. So in this case, if we on charge arrow, we charge the arrow, begin charging. So we have a bool is charging. Is charging. Jesus. So it starts out in false. So charge arrow just sets is charging equal to true. And then our fire arrow set is charging to false again. So on release we set it to false, and then in this case we're going to instantiate arrow prefab. So in this case the player is going to need an arrow prefab. So public game object arrow prefab. So we can get the arrow prefab. So now I can actually instantiate arrow prefab at this dot transform dot position. So I'm creating it at the core of the player. The player is getting it from the core position. Oops, arrow prefab is not capital. And then instead of quaternion rotation. Now remember that the quaternion rotation we've been using is identity. We don't want to use the identity here, because if we use the identity, then it'll always be whatever the prefab is. So if I turn 90 degrees and shoot an arrow, the arrow would come out sideways, because the original prefab direction was that way. So what we want to do is we want to actually do this dot transform dot rotation. And that's the quaternion for whatever the rotation of the player is currently. So in this case, we want the rotation of the player to determine the rotation of the arrow itself. Let me look at my backup code here real quick, because I want to make sure that I didn't do. Yes, that's exactly what I did. So in this case, this is perfectly fine for what we want, but we're going to go take this a step further. This transform would only get the rotation, the X rotation. Well, what if we aimed up? The arrow would obviously not come out like flat like this and fire upwards. Instead, it would take off the camera. So in this case, the player shoot also needs a camera reference. Just like we did before, we are going to have a camera in the thing. So this time, in this case, we want the camera transform rotation. because the camera rotates in the world space as well with the object, because the transform of the camera is combined with the transform of the player object. So that rotates on the y-axis and the z-axis when we look up. So by transforming over the camera rotation, we actually the arrows will actually point upwards when we look up and shoot upwards. So now we instantiate an arrow prefab. Well, if we instantiate an arrow prefab, it'll just drop to the floor because there's no physics. So in this case, we need to get the physics component from the arrow prefab. So just like before, we'll do game object temp equals, and we'll cast it as a game object. And then temp, we'll do a rigid body, temp rigid equals temp dot get component rigid body. So this gets us the rigid body from the temp the temp object. So now the temp rigid body temp rigid dot add relative force we want to apply a relative force to the to a new vector 3 value 0, 0, 0. So now we have a new vector 3, 0, 0, 0, and so now we're adding a relative force to it. So we want the forward vector. So in this case, we actually want to change the z value of the relative force, because that is our forward vector if we're talking about relative force. Just like before, forward is z, to the right is x, and upward is our y value. So we're not shooting it up when we point forward, we're shooting it forward when we point forward. So we want it to be applied to our relative force. Now, how much force do we want to put on this value? Well, that is another good question. So in this case, I can look over, I can do is charging, right? So if we're doing a charging value, we can do a float charge amount equals 0. We'll say charge amount equals 0. And then we're going to have a charge max amount of, let's say, 2,500. So that's 2,500. That's a ton if you think about it. And then we're also going to have a charge, not amount, but a charge rate. So this is how fast it gets to 2,500. So we'll do 30 for now, and then make all these public. So I can modify them in the editor. Is charging doesn't need to be public. So on mouse down, is charging becomes true. On mouse release, fire arrow, is charging becomes false. Instantiate a object, get the rigid body, then apply a relative force to the rigid body at the amount of charge. Wow, why did I put 2 M's? Is that the amount? Yeah, it's not 2 M's, it's 1 M. It's 11:53, it's midnight, it's about time for me to go to bed, so I'm just making stupid spelling errors. So, so in this case, charge amount. So on update, we do want update. So we want if charge amount is greater than or equal to charge max amount, charge amount equals charge max amount. So it can't go past its max amount. And then if is charging charge amount plus equals charge rate. So we add 30, we try the charge rate to charge amount until it reaches max amount, and then on release we send it off at amount charge amount. Now, so let's see what happens here. Let us attach the player shoot to our player object. Here. So now let's look at our player. So our player now has this script here. It needs a camera object, so we need to drag the player camera onto that, and it also needs a arrow prefab. So let's grab our arrow prefab. So now that's all fun and dandy right there. So now we need the mouse input script to affect the player shoot script. So the mouse input script now needs to know about the player shoot script. In this case, we can go back to our input, mouse input, and we're going to require a type of player shoot script. So this requires a player shoot now. So that way we can guarantee that there will be a player shoot object, right? So now we're going to get the player shoot object, player shoot, the player shoot object here, and then player shoot equals this dot get component player shoot. So now we grab the player shoot component. Now I can do if input dot get mouse button down, and I know the left button is 0. So if input get mouse button down, and I know this is a Boolean because it just says if the mouse button gets pressed down, true. So in this case, now I can do player shoot dot send message what was it? Charge. Charge arrow. I don't need it to give anything, so I can do send message options, require receiver. There's no amount that I'm sending to it. I just need to start charging it. Then, instead of get mouse button down, I get mouse button up, 0. So when I release the button, I can say fire arrow. So this sends the message to the player shoot class saying to use the fire arrow method. And now that I have all of this should actually work on our player. So let's find out what happens. Let's grab our thing here. Pew, pew, pew. Now it seems a little wonky, and you notice that even though I keep shooting the arrows out, and even though I'm holding them, I'm not holding them and charging them. For some reason, I keep getting moved slightly, and the reason that is happening is because I'm actually spawning the arrow inside of the rigid body. So what ends up happening is the arrows, you also notice the arrows are like turning weirdly. That's because they're inside the player, and then the physics engine pushes them outside the player, and then causes them to spin weirdly. So in this case, then I'm having an issue. So so the first thing is I'm doing if charge amount is greater than max charge amount, set it, and then I add charge rate if is charging charge rate. So something's wrong with the charge rate. So let me look at the player real quick, and you will see that the charge amount is there. So let's charge it up and fire it. Oh, so that's a problem. So here on fire arrow, we should make sure that charge amount equals 0. So is charging is that, and then charge amount equals 0. So we set it to 0 if we do that. So, and we don't want it to be equal to charge amount. We want it to be greater than charge amount, so that it sets it equal to, and if it doesn't, then it goes at whatever it is. So now that should definitely do something to this whole thing. So in this case, now if we just kind of if we click, it just kind of spits out a bunch of arrows. But if we hold and click and release, it shoots the arrow out like we expect it to. But because it still has that bug where it spawns inside, we're still having little problems. So let's fix that problem where it spawns inside of us. So in this case, transform position, right? It transforms to our position. So in this case, we also want to move it forward. So we want to add this dot transform dot forward. So we want to get whatever this object is. We want the transform, but then we want the forward position of it. So we want it to move one value forward. And I can adjust how far forward I want it by putting this in parentheses and then only moving it and multiplying it by whatever. Because I know forward is a vector 3 that has the z value as 1. So if I multiply it by 0.4, it'll multiply by 0.4f and it will move only 0.4 forward instead of 1 forward. But right now we want it to move 1 forward, so I'll leave that as 1f. Let's see what happens. Now, what should happen is that the arrows should now spawn one value in front of us. There's no more it spawning one value. There's no more spawning inside of the player, right? So now it spawns in front of the player, so I can fire it and have it hit the enemies if I was not awful at this. So now that we've moved it forward, I can move it up, I can move it down, I can move it around. But something to consider is that when you really think about it, I'm here and I'm spawning it from the core position. I'm spawning from the 0-0, the chest position. So the arrows are just coming out of my stomach and just firing forward. And so as soon as we add like a gun to the actual screen, it won't look like the bullets are coming out of the gun. So we're going to create a vector 3 position spawn position, right? So we have this vector 3 spawn position right here. And the vector 3 spawn position is going to equal, I'm actually going to have it equal the camera transform. So it's going to look at so now we're choosing the head position, so it looks like it's coming straight out of the camera. So we'll do the camera position and then the camera forward. So the camera forward, if I've rotated up, the camera forward is always one value in front of the camera's face. So so I can do plus camera dot transform dot forward. So that should make it look a little more like it's coming out of the camera and shooting directly forward. Spawn position. So now we spawn it at spawn position. We spawn the arrow prefab at spawn position with the camera rotation. So now the arrow should look more like it comes out of the player's face. As you can see, it looks like it is literally coming right out of the player's face. Now we don't want to. I don't think we want it to come directly out of the player's face, but you know, you see what I'm saying. It's shooting directly out of the middle of the screen instead of coming out at like the chest position down here somewhere. Something else to note is that I noticed that I can spawn like 1,000,000 arrows all over the place, and the arrows never go away. They never, ever, ever go away. Even if they hit an enemy, if they hit a wall, they just never go away. And normally, you know, that's not something you want, because then you get like, if you had like a rapid fire, it would just shoot 1,000,000,000 arrows out, and you'd have tons of objects all over the place, clogging up the system. So what we want to do is we're going to go back to object, and we're going to create a new script, and we're going to call this script arrow lifetime, or live time. So arrow live time, we have this arrow live time method here. So we're going to have public float max arrow live time equals, we'll say 10 seconds. That's a pretty accurate time right there. So it'll live for 10 seconds. So, and then I'm going to have a private float called current arrow live time. And that's also going to equal whatever the... So instead of doing that, I'll do in start current arrow live time equals max arrow live time. So I need to do that and this, or else it'll drive me absolutely off the wall. And then, okay, so then on update, current arrow live time minus equals time dot delta time. So that's an accurate representation of time passing per frame. So it'll get the amount of time since the last frame. So if current arrow live time is less than or equal to 0, meaning that it should die, destroy this dot game object. And then on top of that, on the arrow damage, we can actually do some stuff here. So so we can apply damage to whatever, right? If the call.gameObject.tag equals enemy, so if the tag of the object is enemy, destroy this .gameObject. So in this case, I'm basically saying if I have an enemy that I am hitting, then destroy the game object. In that case, we have to make a slight adjustment to our prefabs real quick. So we're going to go to our enemy, and we're going to see that there's a tag untagged. So we're going to add a tag for enemies. Call this tag enemy, right? And then we'll go back to our enemy prefab, and then we'll tag it as an enemy. So now when I create it, now when the arrow hits the enemy, when the arrow hits the enemy, the arrow and the object die. Otherwise, it gets dropped on the floor here, and then it only lives for 10 seconds, and then it dies as well. You'll see them start to despawn off the ground in it's 10 seconds, so it's actually a pretty long time for them to live. I like 10 seconds because then you forget that they were sitting there on the ground. Oh, we never attached the script. That's right. We never attached the script to the arrow object. I'm done. Scripts object. Actually, we'll just go to prefabs, arrow, add component, scripts, arrow lifetime. Arrow lifetime is 10 seconds. And also, arrow lifetime of 10 seconds will allow you to like create things that they just got forced. Those enemies just got forced out of each other, so they were like sliding around, which is always something fun that can happen. So now or we just spawn a bunch of objects, and they should despawn in 10 seconds. Should. Yep, there we go. They start to despawn, and eventually they all disappear. So that's so now I don't have to, now we've got our game. Whoa! The input bug with the window size. So window resizing has that. There's a bug where if you resize the window while you're holding an input, it locks the input until you press it again. So it just assumed that my S key was pressed down because I resized the window while the S key was pressed down. That's a Unity thing, and normally it's not a big issue because you either do full screen or the window is locked size, like a locked resolution. But anyway, so now we've got our arrows, we've got our enemies, so now we're going to create a game object. We're going to call this our bow object, and then our bow object is going to have a cube object that I'm going to make 1 by 1, or not 1 by 1, 0.1 by 0.1, and then I'm going to clone that cube object, and I'm going to move 1 up. We're gonna use these objects to so I'm gonna do this at a 60. No, not 60. I'm gonna do we'll move it up 0.3 and go at a 30-degree angle, and then this one will move down 3, so negative 0.3, and be at a negative 60 or 30. And then we'll move them down a little bit more, so this will be 8.4, and this will be 8.4 until they touch like that. Touch. And then we'll add one more thing. We'll add a cylindrical at 0.01, and we'll make it real thin, and it will go between the two here, and we'll make it a height of 0.9, so 0.8, 0.7 will just barely fit. So there we go. So now we have our bow object here, and I'm pretty sure I need to rotate this by like 190 degrees, but anyway, we'll put this bow object inside the player camera up here, and then we'll set the value to 000, and now we can go zoom in on it, and now it's inside the camera, so now we can pull it out of the camera here. Right now the camera is looking where? Ooh, it's rotated that way. So the player 0, and we're going to actually pull the camera out this way, and you'll see that in the camera view here that it's actually doing that. So now I'm going to over the y-axis 180 it, and we'll pull it down a little bit, and now it is in our camera view. So now you can see that it's in our camera view, and if I run the game, you'll see that the bow stays in the camera view, and then although it doesn't look like the arrows are coming out of the the bow, it looks like they're coming out of the camera. So what we can do to fix that is a very interesting thing. We can just adjust those values over in our script. So now that we've, since the gun is the bow is locked to this. One other thing we're going to want to fix real quick is we're going to want to do similar to what we did before, is remove all of the colliders from the box, and from the bow. And and the reason is because if we move it closer to the bow, what we can do is fire an arrow while walking sideways, and it'll hit the tail and cause it to spin out. So we don't want the gun to actually have collision, so that we don't end up screwing up the arrow trajectory. So let's go back to our shoot here. So now we have our transform forward, which is perfectly acceptable. It's a perfectly happy forward of 1. So we're going to leave it at 1. So we're going to do a bunch of transforms here. So now we're going to do another one of these, which is going to be, instead of the camera forward, we're going to do the camera right attribute, which is the axis that points out this way, so it's 1 in this direction. There's also a left attribute and a down attribute and a back attribute, I believe, backward. Up. Where are they? I'm trying to look for all of them real quick here, just so I can do all of. Or maybe it's just the forward right. I thought there was a left. Yeah, no, it's forward, right, and up. So you can just inverse them. So, but in this case, we have the right. So the inverse of right is left. So if you did negative right, if you basically did this, it would be a left attribute instead of a right attribute. So in this case, we want to move it right, but we don't probably want to move it right 1. We probably, but we'll see. How about this? We'll see what happens when we move it right 1. And then we will find out, and it'll be a glorious time had by all, and it will be a fun experiment with direction and things like that. So in this case, now the arrows look like they're coming from the outside. They're coming from way over there, and not from the bow. So we probably want this to be like a 0.5, so times 0.5f. So now it'll move right half the distance that it did before. And it'll do a, it should be coming more from the bow component. Aha, there we go. Now it looks like it's coming from the bow, but it's a little bit too high up. So what we can do is we can do what I was talking about just then, is we can add the transform up, but we can do it as a negative value, so I can move it down. Let's say I'm going to move it down 0.2. So it's only going to adjust by 0.2, but it's going to move down away from the camera's position by 0.2. So now it's coming from there. Okay, so let's move it down a little bit further, because I need to go a little bit further down. So let's say 0.4. Make it a little bit further down. It's probably a little too far. Maybe a 0.3 is perfect. Alright, there we go. Now they look like they're coming out of the bow proper. So now we can color the bow and call this a game. I mean, technically, there's a lot more we could do. We can do, but for now, for the most part, this is the minimum that we need to call this a game. We could add a scoring system. We can. So the big thing, the last thing I want to add before we call this the final version that matches the version that I had shown you at the beginning of the stream, is I want to add mouse lock. So on this case, I'm going to, if mouse button down, I'm going to do a cursor dot lock state. state equals cursor lock mode dot locked. So now it'll lock it in the center of the screen. I think lock state is lowercase l. And then we're going to come over here and do cursor dot visible equals false. So now you won't see the cursor in the center of the screen. You'll no longer see the cursor in the center of the screen. So in that case, we're going to want to come over here. I'm going to do a real quick text one. So you'll see that new text shows up now in the middle of the screen. So I can do 2D. I'm going to switch to 2D mode, and I'm going to head over to our text. So now we have our canvas here. So this canvas is our HUD. This is all of our UI elements. So in this case, I'm going to go to our text element here, and I'm just going to do a quick plus sign, and then set the color to white. And then I'm going to set the font size to 32. I'm going to set this to overflow so that it shows regardless of how wide I make this object. And then I'm going to have it centered right in the middle of the screen. And I'm going to make sure that it scales with the center of the screen by selecting this. These are all things that I'm not going to super get into, but just make sure to set it to center, and then just add the text plus sign in the center of the canvas. So you can find the center of the canvas by dragging it around. You'll see those two center, because you have it set to center middle. It'll have those two lines. This is center vertical, this is center horizontal, or vice versa. And so that way there's a plus sign that shows up regardless of your size. You know, you can make it really wide or whatever. It'll always show up right in the center of the screen. And then when you click for the first time inside the window, it will lock your mouse cursor to the window, making it much easier to play. However, the one catch that I did run into is that the arrow is not exactly, the plus sign is not exactly accurate to where because we've shifted it over this way a little bit, the arrow is not exactly accurate to where you are actually shooting. It's actually slightly to the right of the arrow of the plus sign. So take that into account. We could pull the bow in a little bit and then pull the spawn point over a little bit to make it more accurate, but for the most part, because like if I did it here, it'll just miss entirely. It's to the right of the because we're firing from the bow, and the plus sign is directly smack dab in the middle of the screen. But that is it. Normally on standalone applications, the cursor unlock will be escape. But in this case, I can Control P to stop playing, and then it unlocks again. And so that is your game. Now, if you want to build for your friends or want to give it to somebody else, go to Build Settings, and you can build to Windows, Mac, Linux. And then in my next few tutorials, I'm going to cover how to do controller inputs, so you can play it with a controller. I'm going to cover split screen multiplayer, so you can play on the same PC with split screens. And then Android, I'm going to do Android controls. So I'm going to do the controller and the Android controls in the probably in the next tutorial set. So this was just building the 3D game, and then in the next tutorial I'm going to do Android controls for a game, and then controller support, USB controller support for the game, and then next we're going to do split screen multiplayer, and then the next one after that will probably be networking multiplayer. Very simple networking multiplayer, but you'll be able to play with multiple players, and everybody can shoot arrows at each other, and it'll be a fantastic time. So after that, so you just build for whatever version you want, Mac, Windows, Linux. Make sure to add your current scene. So in this case, scenes game Unity. I want to add that scene. Build done, and you can send the files, the folder, that gets generated by the build. You can send them to your friends. They can install them on their computers and play there. So yeah, there you go. There is your first 3D game. Hope you enjoyed the whole tutorial and got through the whole thing. Stuck around long enough to see the whole thing through, and I hope this really helped with your understanding of Unity. If you have any questions on any of the things that I covered, go and if they were in a specific video, just go leave a comment on the video. I'll try to respond to as many as I can on some of the specific things that I did, but I think I hope I described them well enough so that you understand what's happening and how they all work and how everything gets put together in the end, how to create each object and how to interact with between objects and things like that. If you haven't already, I do normally do game development on live stream on my channel, twitch.tv/Snowdrama. I try to do it every day. I actually took today off so I can make these videos. And then I also have my Twitter, which is @SnowdramaGames. So if you wanted to go follow on the Twitter and follow over on Twitch, I do game development streams over on Twitch when I'm not playing games, which is most of the time. Most of the time I'm making Unity, working on my Unity game. And so I do game development over on Twitch. Check me out on Twitter. I tweet out when I'm streaming and what projects I'm working on. I'm really active over on Twitter, as well as subscribe to the channel so that I can so you can get more videos for the rest of my tutorial series when I manage to post all of those. And so yeah, I hope everybody enjoyed that, and have a good one. Stay standing up. We're going to freeze the rotation on our X and Z coordinates, but not on our Y because they can rotate. So now, when I go back into the game here, we will see a green wall. So now we can walk up to the objects and kind of bump into them and push them around because they actually exist in physical space. And so that's cool. That's a really cool spiel here. That's something that they managed to do. So now they kind of just hang out, right? So now the next thing we want to do is we want to be able to shoot them. So what we're going to do is add a new script to them. So let's go back to our enemy folder and create a C# script called enemy health. And so this enemy health class is going to contain everything you need to know about enemy health. So reload. So enemy health. So we're going to do public. We'll do a public float. ENEMY. No. Enemy max health. And then we'll do a float current health, and then on start we'll set the enemy current health to enemy. So I had an issue with my recording, so I had to there you'll see a couple of things that didn't exist a few minutes ago if you just transferred over from the last video. I apologize in advance for the fan. It was getting very warm in here, and I am very, very toasty. I'm getting a little on the toasty side, so I just had to do that. So anyway, we're going to create an enemy generator, just like we did with the building generator. So this one's going to be called. We're going to create a game object called enemy generator. And then we're going to create a script in the enemy that I've already created because I screwed up the video, is the enemy generator class. There's still nothing in it. We haven't touched it yet, but there is I did create it. So I just created a new C# script called enemy generator. So in this case, enemy generator will attach to the enemy generator object right up here. And then we're also going to create a prefab for our enemy. So let's create a 3D object. Oops. Not an empty object, a 3D object capsule, just like we did before. And then I'm going to call this capsule enemy, right? So then enemy we're going to create a material. I already created the material, just like we did before. Create material, and then just change the color. In this case, we changed the color to red. And then we're going to apply the enemy mat to the enemy. So the enemies stand out as these bright red things. So this is our enemy, and we have our enemy generator. So in our enemy generator, we're going to open up the enemy generator script. And then we're going to create two public values, or three public values. First one's going to be game object, enemy prefab, just like we did with a lot of the other prefabs that we've seen, especially in the city generator, which is the building prefab. So now we have our enemy prefab, and then we're going to do a public float arena size, or arena size X equals, we'll do 50 for now. That'll be our default size, and then we'll change it later in the editor. So arena size Y is also 50. So these values are, these arena sizes are going to be how much space that we have to put these objects in. In this case, just like we did on start, we're going to have a for loop, but this time we don't need a nested for loop. We just need a single for loop. So for int I equals 0, I is less than or equal to. Now what are we going to do? There's going to be a public int, because we can't have half of an enemy, enemy size. And then finally, we need the quaternion identity. So now it'll instantiate an enemy prefab at a random amount between 0 and 50 in the enemy prefab type. So let's go to our enemy generator here, and now it needs a prefab. So let's go back over here to our prefab list here, and then let's drag our enemy into the prefab list, and we can delete the enemy from the scene, and then go to enemy generator, and then attach this prefab to our enemy prefab. Again, we could also click the button, look at all of our assets, and click the enemy object. So now that we've added the enemy to our enemy generator, let's see what happens. So we run the game, and it creates, bam, exactly what I expected. From 0, 0 to 50, 50, it creates a bunch of objects, a bunch of enemy objects. So it just creates a bunch of them. Now the thing with these is that if we were to go into our game here, we can walk up to them and bump into them like buildings. They don't move. So what's wrong with them? Well, in this case, they don't have rigid bodies like we expect them to. So let's go back to our enemy prefab here and add a component physics rigid body. And just like the players, because we want them to see count equals 100. So we're going to spawn 100 enemies. So is less than or equal to enemy count. In this case, actually, we're going to spawn 101. So let's spawn only 100. So just don't put the equal sign, so that we only do 0 to 99. And then last but not least, I plus plus, so that we increase I every iteration. So in this case, now we can just instantiate a enemy prefab at new vector3 so in this case we're going to do the x and z coordinates just like we did with the building scale. We're going to do random.range arena size or sorry, 0 to arena size X. And then 0, we're going to make it 1 because I know the height is 1. And then we need it to be 1 so that they don't end up buried in the ground. And then finally random range 0 to arena size y for the vector.